Hello, can you hear me?
Yes, sir. Good evening.
Yeah, good evening. Okay, how is it going? What did you have a test this weekend? No, right?
No,
Okay. Since the last class, have you tried anything in physics and maths? Anything?
no, sir. I did one chapter of SLONI.
Hmm. And in physics,
Sir, no.
you have not tried friction and all yet.
Sir, not yet.
Okay. So you are focusing more on maths. In the last few days, what were you doing since Friday?
Sir, maths.
Okay. Tell me, is there any problem in SLONI stuff?
Uh,
Any any questions that you couldn't solve?
Sir, chapter 8,
Exercise number?
exercise number 18.
Okay, 1 second.
Sir, question 8.
If sine theta plus sine phi, that one.
Yes, sir.
Sine theta plus sine phi is equal to A, and you're given cos theta plus cos phi is equal to B.
Hmm.
You have to find the value of tan of theta minus phi by 2. Okay. Fine. So these two equations you have to use to get that. So if you know sin C plus sin D, what is sin C plus sin D formula?
2 sine C plus D by 2 into cos C minus D by 2.
So from here, using that formula, you can say it is 2 sine theta plus phi by 2 cos theta minus phi by 2 is equal to A, right?
Yes, sir.
And using cos C plus cos T formula, what do you get from
2 cos theta plus pi by 2 cos theta minus pi by 2 equals B.
Cos theta minus phi by 2 equals B now. So
Hmm.
from here, obviously, the first impulse is to divide it, but that won't help you, right?
Hmm.
Because if you divide it, you will remove the stuff that you need.
Hmm.
Do you understand what I'm saying?
Yes, sir.
You need tan of the angle theta minus phi by 2, not theta plus phi by 2. So you have to do something else here. What you can do here is square it and add. Square, square, and add. How will that help us? Because one cos square will be common, right?
Yes, sir.
So if you think about it, it will be 4 cos square theta minus phi by 2. And inside the bracket, there will be sine square plus cos square, right?
Yes, sir.
Which will become 1 because they have the same angle. It is going to be equal to a square plus b square.
Yes, sir.
So that is a nice way in which we have removed basically the angle theta plus phi by 2. That angle has been eliminated.
Hmm.
And you have gotten that cos square theta minus phi by 2 is equal to a square plus b square by 4. Right?
Yes.
If you know cos square, obviously you know sec square. Right?
Yes, sir.
Sec square is 4 by a square plus b square. And therefore 1 plus tan square is equal to 4 by a square plus b square, right?
Yes.
So tan square of that angle, theta minus phi by 2 is equal to this minus 1. You get 4 minus a square minus b square by a square plus b square.
Yes, sir.
Correct? So square root of that is the answer.
Yes, sir.
Do you understand what is happening?
Yes, sir. Got it.
We use the two sum formulas. After that, we try to remove the angle that we don't want. We don't want the sum. So we square and add. That is a standard technique that you need to be aware of, squaring and adding.
Mm.
Especially useful in eliminating trigonometric expressions. Okay, what is the next doubt?
So after that, sir, exercise 19,
Hmm.
sir, question 8.
Anything, no other problems in this exercise?
No,
The
sir, not,
previous one?
sir,
For
not yet.
example, exercise 18 only, question number um, 18, have you gotten it?
Yes, sir.
How, tell me.
Sir, firstly, we can write cos to the 4 5 pi by 8 as sine to the 4 pi by 8. And similarly for cos to the 4 7 pi by 8.
Basically, we have to prove sum of these cos to the power 4 powers is equal, find, no, we have to prove that it is equal to 3 by 2, right?
Mm. Yes.
So, what is your first step?
Sir, we can say that cos of 5 pi by 8 is sine of uh, is basically sine of pi by 8. Cos the sine of minus sine of pi by 8.
Why are you doing that? I mean, sine, how are
That
you
work.
converting? You're doing
Sir,
4 pi by 8
cos
plus
of
pi by 8.
yes, that is minus sine pi by 8.
Okay.
And
Fine.
okay, cos to the 4 into that angle is sine to the 4 pi by 8.
Hmm.
And similarly for sin pi by 8, we can say it's sine to the 4 3 pi by 8.
The 7 pi by 8.
Yes. And then we can say sine to the 4 pi by 8 plus cos to the 4 pi by 8 is sine
Hmm.
square pi by 8 plus cos square pi by 8 the whole square minus 2 sine square pi by 8 cos square pi by 8. 1 minus 2, yeah. Yes, sir.
Mm-hmm. Then
Sir, similarly for
that's
that,
fine. What about this? How do you do this?
so this is 1 minus 1 by 2 into sine of sine square pi by 4.
Hmm.
And similarly, this is equal to 1 minus 1 by 2 into 1 by 2, which is 3 by 4. So similarly, you get for the other part, you get
Hmm.
the sum of those two as 3 by 2.
Okay. Exercise 19. What is the doubt?
So question 8.
Okay. Question 8 is saying uh, cos of pi by 15, cos of 2 pi by 15, cos 3 pi by 15 till 6 7 pi by 15. 3 pi by 15, 4 pi by 15, 5 pi by 15. Okay, all the 7 ones. We have to prove that this is equal to 1 by 2 to the power 7.
Mm.
Okay, fine. So because 15 is divided by 15 is a little weird. So it will be easier if you think about it in terms of degrees in this question. So it is like pi by 15 is 12 degree, right?
Mm.
It is like this. This is the situation, right?
Yes,
Now, out of this, you should know the value of cos 36.
yes, sir.
Do you know cos 36?
Yes, sir. It's
You have to remember one angle of 18 degree and one angle of 36 degree, either sine or cos. You have to remember it.
mm.
Do you understand what I'm saying?
Yes, sir.
one ratio, either sine or cos, or sine or cos of 18, you have to remember one of them, because if you know one of them, you can find the other, right?
Yes, sir.
So tell me, what is cos 36?
Root 5 plus 1 by 4.
Do you know the proof of how to get it?
Yes, sir.
How?
Sir, we can say that cos of 36 degrees is sine of 54 degrees.
Mm-hmm.
And suppose we take theta as 18 degrees, we can say cos of 2 theta equals sine of 3 theta.
Why are we saying that cos 2 theta? Oh, okay. Cos 2 theta is sine of 3 theta. Fine.
Yes. So then if you expand that, like you can basically get that is,
What do you mean expand this?
sir, cos square 2 theta, cos square theta minus sine square theta equals
Mhm.
4 sine cube theta,
No,
4
this
3
is
cos
3
theta,
sine theta
3
minus
sine
4
theta,
sine.
3 sine theta minus 4 sine cube theta.
Mhm.
Uh,
Now what?
so then cos square theta, again we can write it as 1 minus, so it's basically 1 minus 2 sine square theta is 3 sine theta minus 4 sine cube theta.
Mm-hmm.
So then bring everything to one side. 4 sine
Okay.
theta minus 2 sine square theta minus 3 sine theta plus 1 equals 0.
Mm-hmm. Now what?
So
There is a standard, this is a cubic equation. There is no normal way to solve it except guessing one root.
mm,
You can easily see that sine theta is equal to 1 satisfies this equation.
yes, sir, sine theta equals 1. So you can
Can
take that out common. Like
sine theta minus 1 is a common factor, right?
yes, sir, and then you get a quadratic. You can solve that quadratic.
Why are we saying that this will never be 0? Because we know that sine 18 is never 1, right?
Yes,
So if you can factorize it, but you know that this factor is never 0, right?
yes,
If so, that means the other factor, which will be a quadratic, must be 0.
yes,
That quadratic can be easily gotten by dividing this with sine theta minus 1, right?
yes,
Once you get the quadratic, you will solve it by quadratic formula and you will get the value of sine 18.
yes,
Once you know sine 18, finding sine 36 or cos 36 should not be a problem.
yes,
For example, cos 36 will be 1 minus 2 sine square 18, right?
yes.
1 second, hold on.
I'll talk to you later.
Okay, so that is the standard method by which you find your sine 18 and cos 36 and so on, right?
Yes, sir.
But you cannot do this method all the time. So you need to remember at least one value.
Mm.
What is sine 18 or cos 18? What do you remember?
So sine 18 is root 5 minus 1 by 4.
Hmm.
Cos 18 is root 5. Uh, uh, is,
Cos 18 you don't need to remember. Just remember one of them, which is the nicer.
mm,
Remember sine 18 and remember cos 36.
mm,
Do you understand what I'm saying?
yes, sir.
So if we have that, then you can see that obviously cos 60 value we know already, right?
Yes,
So we can say half for cos 60, and for cos 36 I can write what? Root 5 plus 1 by 4,
yes,
right? And I have left what? Cos 12, cos 24, and cos 48 is there, and cos 72 can be written as sine 18, right?
Yes.
And cos 84 I will write as it is because I don't know the value right now. But sine 18 I know, right?
Yes.
Sine 18 is what? Root 5 minus 1 by 4.
Mm.
So I'll put that here, and if you put that here, it will multiply with this, become 5 minus 1 by 16, right?
Yes.
And there is a half outside also. So this is 4 by 16, so 1 by 4 and 1 by 8, basically.
Mm.
1 by 8, and you have removed this, and you have these left,
Yes.
correct? Okay. Now you have cos 12, 24, 48, 84. Now let's do a grouping here. What grouping I would see is 12 and 48 together
Mm.
because they add up to 60. And I will also group 84 and 24 together. Why?
Mm.
Because the difference is 60, right?
Yes.
And if I multiply by half and take a 2 inside in both, we can expand both, right?
Yes.
So I'll multiply by half. So it will become 1 by 32. And inside I have a 2 cos 12, cos 48. And inside I have a 2 cos 84, cos 24.
Yes.
Are you understanding what I'm saying?
Yes, sir.
And then expand it. 2 cos c cos t would be the sum of the cos c plus d and cos c minus d, right?
Yes.
Both cases we can do that. So it is becoming 1 by 32 cos of this plus this. So cos of 60 plus cos of c minus d. So cos of 36, right?
Yes.
The negative sign in 36 doesn't matter because cos is an even function. Cos of minus theta is equal to cos theta, right?
Yes.
And similarly, here you are getting cos of 108 plus cos of 60, right?
Yes.
And cos of 108 can be written as minus cos 72.
Mm.
Why? Because cos 180 minus theta is minus cos theta, right?
Yes.
Okay. So now we have here, notice that all of these values I think we know now, right?
Yes.
Because you have half. Cos 36 we already knew is root 5 plus 1 by 4, right?
Yes.
And here we have half, and this is minus sine 18, right?
Yes.
And sine 18 we know is half minus root 5 minus 1 by 4.
Yes.
And outside there is 1 by 2 power 5,
Yes.
correct? So after this, it is a matter of multiplying and simplifying. So let's do that. So you get, basically, if you take common denominator 4 and 4, you get what? You get on top here 2 plus. So it is 3 plus root 5 by 4. And here it is 2 minus root 5 plus 1. So 3 minus root 5, right?
Mm.
And the top part will multiply and rationalize. You'll get 9 minus 5, 4 by 16. And you have outside 1 by 2 power 5. So overall is becoming 1 by 2 power 7.
Yes, sir.
So it's a simple matter of knowing certain values and grouping it correctly. If you group it correctly, it will be fine, right?
Yes, sir.
Okay. What is next? Tell me.
Sir, that's it.
So that was chapter 8. Chapter 9 will have more identities. You need to try chapter 9 as soon as possible.
Yes, sir.
Uh, there is a lot to do there. So you need to try that. Other than that, in straight lines and circles, what are your issues? Tell me.
Sir, nothing.
Have you done any work there?
No.
No, matlab, what have you done so far?
Sir, does the Fiji work like not?
Hmm. So Fiji assignments and all, there is no problems.
Sir, no problems.
Circles, how much theory has been done so far?
Sir, circles, the equations of the circles like different, like
Hmm.
the circles touching the given line, and
Mhm.
then sir, endpoints of the diameter, then the basic
Like how
equation.
many classes of theory have happened in circles?
Sir, one.
Only one class.
Hmm.
Okay, so we'll discuss a little bit of circles theory because you don't have doubts. If you had doubts, you would have done doubts. Okay. Uh, so circles theory. What is the standard? What is the definition of a circle?
Sir, a circle is the collection of all the points in a plane at a fixed distance from a given point.
Right. So it is the locus of points which are equidistant from a fixed point, right?
Yes, sir.
Which are equidistant from a fixed point. And that fixed point is known as the center, and the distance is known as the radius, right?
Yes.
Now, the very simple circle equation would be a equation like this: x square plus y square is equal to a square.
Hmm.
This is basically, you are saying distance from the origin, x minus 0 whole square plus y minus 0 whole square is equal to a, right?
Yes.
Here the center becomes what? 0, 0.
Hmm.
And the radius of the circle becomes a, right?
Yes.
So in general, this is the equation of a circle which has center 0, 0, radius a.
Hmm.
However, obviously, circles can be such that they have center at a random point. So you could have center at a point, like let's say alpha comma beta, right?
Yes.
This is also a possible equation of a circle. Here center is alpha comma beta and radius is r, right?
Yes.
So if you expand this equation, you will realize that it will start looking like this: x square plus y square minus 2 alpha x minus 2 beta y plus alpha square plus beta square minus r square equals 0, right?
Yes.
So this suggests that a general circle equation will be like a quadratic function in both x and y, right?
Yes.
You can see that there are quadratic terms in x and y here, linear degree terms also and constant term also, right? Are you understanding what I'm saying?
Yes, sir.
So the equation of a circle here, which is given in the form of center and radius, can be converted into a general standard equation, which is a quadratic in x and y. So in general, the idea is this: if you have a situation like this, ax square plus by square plus 2hxy plus 2gx plus 2fy plus c equals 0, plus c equals 0. This is known as a 2-degree equation in x and y. Okay.
Yes.
2-degree equation in x and y because both the variables x and y have degree 2, right?
Yes.
And you can see here that there are all types of terms. There is x square, y square, xy, which is a degree 2 term. There is linear terms here, and there is a constant term, which is degree 0, right?
Hmm.
In coordinate geometry, you will realize that all of it is the study basically of this equation. Okay.
Hmm.
All the chapters in coordinate geometry technically are a study of this equation because this equation can represent many things. It can be pair of straight lines, right?
Hmm.
Have you studied pair of straight lines so far?
Yes, sir.
So you already know that this equation can represent a pair of straight lines, right?
Yes.
Do you know the condition when this is a pair of straight lines?
Yes, sir. Delta equals 0.
And that delta you need to remember, it is ABC plus 2FGH minus AF square minus BG square minus CH square, right?
Yes.
This delta discriminant must be equal to 0 for this general equation to be a pair of straight lines,
Hmm.
right? Now, do you know why this has to be 0?
Yes, sir. Sir, suppose you take it
Hmm.
like a1x plus b1y plus c equals 0 into a2x plus b2y plus c2 equals 0.
Mm-hmm.
So then you multiply it out, you will get some equation.
Mm-hmm.
So then you can basically compare the coefficients, you get few like quadratic equations. If you solve, you get this condition.
No, that is not a correct method because you will get many weird conditions. How will you get this from there? If what you just now said is like saying, let's take two straight lines which are factorized out of this, right?
Yes,
If you take Lx plus My plus N and Px plus Qy plus R, these are my two straight lines which are factoring, which this general equation is getting factored into.
yes,
If you multiply it out, you will get six variables here and conditions on six variables to A, B, H, G, F, and C. Right?
hmm,
I don't see any normal way in which I can get prove this result. Do you see any way in which it can be easily proved? It's almost like you'll have to multiply it out and check everything. You'll understand what I'm saying.
yes, sir.
For example, if I have to get A, A should be LP, right?
Yes,
B should be QM,
yes,
right? Uh, every term after that will be a little complicated, right?
hmm,
Because there will be multiple ways you can get X, right?
yes,
XY term will be simple. 2H will be basically XY can happen LM, no, L and Q and M and P, right?
hmm,
You understand how complicated it will become.
yes,
How
sir.
will you prove that this is zero? Like that is not a good method, even though it is possible to prove it from here. You will have to brute force multiply everything and see, right?
Hmm,
Also, suppose you did this, how would you get the idea that this has to be zero? Like, how did this expression come from? Where did it come from? Do you understand my point?
hmm,
Like, why will somebody think of this expression and why will they say that it is zero?
hmm,
There is no normal way from here to suspect that this should be zero, right? Is there
yes,
anything that gives you the hint that that should be zero?
for nothing.
तो क्लास में फिटजी में यही ऐसे ही बताया, क्लास में इस कंडीशन का रीजन नहीं बताया था क्यों हो रहा है ये जीरो.
Hmm.
They must have said something.
Yes, sir. So they said something, sir. They proved it like in a similar way. Like I don't exactly recall the proof.
Did you write it down when they were proving it?
Yes, sir. I wrote it down. Sir,
Check the notes.
sir, 1 second.
Are you able to find anything?
Oh, yes, sir. Wait 1 minute.
Okay, if you're not able to find or understand, then we'll discuss it right now.
Okay. So
कुछ
we just
समझ में नहीं आ रहा है.
check on it.
What is there? What is the saying?
Uh,
Is it based on factoring it like this and then saying something, or is there any other method?
Sir, you take, sir, because they are concurrent.
Concurrent.
No way.
What if they are parallel lines?
Yeah. Oh.
Okay, it is not clear for you, so we'll discuss it. Okay.
Okay.
Um, See, this is the kind of thing that you cannot let happen. This cannot happen. Like, if they say something in class and if they give you some result in class, you cannot accept it without understanding why.
Mm.
You understand what I'm saying?
Yes, sir.
Just because the teacher is saying something doesn't mean you have to believe it. You are studying science, not history.
Mm.
So if you don't know the reason for something, then you cannot really use that result.
Mm.
You have to make a note of it. You have to be like, I need to find the reason. You have to ask me in class. When I was saying, is straight lines mein koi problem hai? You were saying no problem. This is a problem. Do
Mm.
you understand what I mean?
Yes, sir.
You cannot say that no problem if you don't know the derivation, how it happened.
Mm.
And this is the kind of thing that differentiates between the candidates. There will be many students who know the basic formulas and all, but
Mm.
there will be smaller number of students who know how it is happening.
Mm.
That is going to be the difference between you and the others. So you have to have that extra knowledge.
Mm.
Is it clear what I'm saying?
Yes, sir.
You cannot accept anything blindly. Please ask questions and mark things. If you don't understand how something has happened, you need to mark it and you need to ask in class.
Mm.
Okay. The proof of this is there in SL Loney in pair of straight lines chapter, but we'll discuss it now. You can read that proof later. SL Loney coordinate geometry.
Mm.
So The idea is this expression did not magically come from nowhere. Nobody can imagine this expression. Oh, let's think of this, right?
Mm.
There is a reason from where it has come naturally. By derivation, it has come. You don't have to imagine it. So, what you are doing here is you are saying that this equation, you can see that it is a quadratic in both x and y. So, we can express it as a quadratic equation in either x or y, right?
Oh,
What
yes,
I
sir. Yes,
mean
sir.
by
Sir, sir. Yes, sir. And I remember. Yes, sir. Thank you. Yes, sir.
while what we will do here is we'll write it as a quadratic in x, let's say, or let's say we do it in
Sir,
y.
and so y terms as constants.
We will do it in y right now. So let's say by square is the first term and the y term will be this and this, right?
Yes.
So y common, it will be 2hx plus 2f,
Yes.
right? And the rest of the terms will be considered as a constant, ax square plus 2gx plus c.
Yes.
This is my quadratic. I can solve this quadratic by the formula and I can say y is equal to minus of 2hx plus 2f plus minus root over this square 2hx plus 2f whole square minus 4 times b times constant term ax square plus 2gx plus c divided by 2b, right?
Yes.
Now, if you think about it, the quantity inside the root, you can take a 4 outside and 2 will come out and 2 will cancel everywhere, right?
Yes.
You will get minus of hx plus f plus minus root over it is hx plus f whole square minus b times ax square plus 2gx plus c. I have taken 4 outside and this is whole thing is divided by b, right? Are you understanding what I'm doing?
Yes, sir.
Now the point is that if it is going to be a straight line,
So
it
then
must
that
have
thing
the
must be a
form
square.
y is equal to mx plus c, something like that, right?
Yes, sir.
Already there is a hx plus f outside, but if the root is not removed, what will happen? It can never be a straight line if there is a root containing x and all, right?
Yes, sir. So that root must be 0.
That root must not be 0. That root
Or perfect square.
must
Perfect.
be a perfect square. So
Mm.
the thing that is inside the root has to be a perfect square, otherwise the radical sign can never be removed,
Yes.
right? What is inside the root? It is hx plus f whole square minus b times ax square plus 2gx plus c must be a perfect square, right?
Mm.
So this thing can be written as h square minus ab x square. The x term will come from 2hfx minus 2bgx, right? And the constant term will be f square minus bc, right?
Mm.
This must be a perfect square. How can this thing be a perfect square, right?
If the discriminant is 0.
If the discriminant is 0, or you can say that this must be your p square, this must be your q square, and this part must be 2pq,
Yes.
right?
Yes.
Then the whole thing can be written as px plus q whole square, right?
Mm.
So p must be root of this, q must be root of this, and we can say hf minus bg must be pq, right?
Yes.
So if you say hf minus bg is pq, we will say that hf minus bg is equal to pq. Pq is what? Root of h square minus ab times root of f square minus bc, right?
Yes.
And if you square it, this becomes h square f square plus plus b square g square minus 2hfbg is equal to h square f square minus h square bc minus f square ab plus ab square c, right?
Mm.
And you can see h square f square gets cancelled from both sides. And notice that b is there in all the terms, right?
Mm.
So you can cancel one b from every term. And if you cancel one b from every term, notice what is coming. You are
Yes.
getting bg square minus 2h fg is equal to minus h square c minus f square a plus abc, right?
Yes.
Which if you bring to one side, you are getting this condition.
Mm.
ABC plus 2FGH minus this is equal to 0. Basically, this is the condition for the square root to be perfect square. If the square root is a perfect square, it will come out as a linear term and you will get two different line equations.
Yes.
Do you understand?
Yes, sir.
So this is the basic condition. Del is equal to 0 for pair of straight lines. But if del is not equal to 0, there are many other possibilities after that,
Mm.
right? So del is not equal to 0 means this equation is not going to be a pair of straight lines. And in that case, it can be multiple things. It can be circle, it can be parabola, it can be ellipse, and it can be hyperbola. Four possibilities.
Mm.
Okay. So all four cases come under the sub case of del not equal to 0. Right?
Mm.
And so now we'll say that this general equation 2hxy plus 2fy plus 2gx plus c equals 0. If del is not equal to 0, now let's write the conditions for circle. For a circle, you have to have a must be b and h must be 0.
Yes.
Okay. So del should be non-zero. If del is 0, it cannot be a circle. It is a pair of straight lines. Right? Do you understand what I'm saying?
Yes.
Similarly, in future chapters, we will say if h square minus ab is 0, and if h square minus ab is greater than 0, and h square minus ab is less than 0, it will be parabola, hyperbola, ellipse. Right?
Mm.
So these are the four conditions for four different situations, and under the major case that del should not be 0. Right? Now, how do we know that when a is equal to b and h is equal to 0, it is a circle? It is easy to prove that. For example, now we will say we'll put the condition a is equal to b and h is equal to 0 in this equation, right? So we have ax square plus ay square plus 0xy plus 2fy plus 2gx plus c equals 0, right?
Yes.
So basically we have put a is equal to b and h is equal to 0. So this term vanishes and we can say a common x square plus y square plus 2g by a x plus 2f by a y plus c by a equals 0, right?
Yes.
Since a is obviously not 0, because if a is 0, the equation is not 2 degree, right?
Mm.
A is not 0, so we have basically we can cancel this factor out and we can say this is my equation, right?
Mm.
And this equation is a circle equation because we can do completing the square method, right? We
Yes.
can say x square plus 2g by ax. Let's add a g square by a square to it, right?
Mm.
Plus y square plus 2f by ay. Let's add a f square by a square to it.
Mm.
And then we can subtract c by a minus g square by a square minus f square by a square
Mm.
equals 0, right?
Mm.
So notice that this part becomes a perfect square, this part becomes a perfect square. You can write it as x plus g by a whole square plus y plus f by a whole square is equal to f square plus g square minus ac by a square, right?
Mm.
Are you understanding what I'm saying?
Yes, sir.
In the special case that a is equal to 1, which is the usual case that we think about, the equation starts looking like x square plus y square plus 2gx plus 2fy plus c. Right? This is the standard circle equation. Standard equation of a circle. It's a special case that a is equal to 1, equal to b, and h is 0 in the general equation. The general 2-degree equation is the most important equation. From there, in the special case, we get this situation where it is clearly a circle, and we can easily show that this is x plus g whole square plus y plus f whole square, and you have c minus g square minus f square. So it goes on the other side, it's f square plus g square minus c, right? Now, as long as f square plus g square minus c is greater than or equal to 0, you get a real circle, right? Because this quantity must be the square of the radius, right?
Yes.
So it has to be a positive number for the radius to be real number, right?
Yes.
You understand what I'm saying?
Yes.
So radius to be real, radius is basically defined as root over f square plus g square minus c. So in the original equation, you must have f square plus g square minus c is greater than or equal to 0, right? If it is negative, this quantity, then the circle is imaginary. You don't have a circle, right? If it is equal to 0, then it is not a circle, it's a point, right?
Yes.
Which point? The point minus g minus f, which is also known as the point circle. It is a circle with radius 0 in that case. And if it is positive, then you have a positive radius circle. The center of the circle is minus g minus f. Because notice that this is like saying distance of x from minus g, right?
Yes.
And distance of y from minus f is equal to a square, where a is the square root of this. So you need to remember, in the standard equation, circle center is minus g minus f, and radius is root over g square plus f square minus c. Right? After this point, there are some special cases like circle which touches the x-axis or circle which touches the y-axis, right? There are also equations. For example, if the two endpoints of the diameter are known, you can write the equation of the circle easily, right? All of those things depend on certain geometrical properties. For example, if the endpoints of the circle are known, what is the equation of this circle? Endpoints of a diameter are known.
Sir, it is x minus x1 into x minus x2 plus y minus y1 into y minus y2
equals
0.
Why is this correct?
Sir, because you can say that the endpoints of the diameter, if you draw a line to any point on the circle, like say px comma y, that is the point, or ph comma k. ph comma k.
ph comma k, what do you mean?
That point of intersection.
Point of intersection?
So that point where it's subtending the angle on the circle, right?
Then?
Yes, sir. So that if you take the lines joining ph comma k to x1, y1 and ph comma k to x2, y2, because they're perpendicular, the product of the slopes is -1.
So this depends on the property that the angle subtended by a diameter is always 90 degrees.
Yes, sir.
Right? And based on that, we are writing this. Obviously, there was another way to get the equation because these are endpoints of a diameter. You can easily say that the midpoint is the center.
Yes, sir.
Midpoint is x1 plus x2 by 2, y1 plus y2 by 2, and the distance between them is the radius, right?
Yes.
But obviously, this is faster. You need to start reading SL theory for circles. From circles chapter onwards, you need to read SL. So don't wait for your Fiji teachers to teach you. Already you have to start reading it and going ahead in SL. The first priority is to doing SL only. After that only you have to do Fitzgerald exercises. Okay. From this chapter onwards, any chapter in coordinate geometry, first priority is SL only. Okay. So make sure that you start reading the articles of theory there, start doing the exercises. If it is obvious question, then you don't have to spend time on it. But as soon as you see the exercises, you will realize very soon that the questions in SLONI are not at all obvious. Okay, so you need to try as much as you can there. There are a lot of exercises, a lot of theory. They're probably divided into two different chapters here in SLONI. So you need to get started with that as soon as possible. Once you read a little more, then we'll discuss in detail if there is anything that you're getting stuck at. Okay. So for maths, the work is chapter 9 in trigonometry and SLONI circles. Okay. For physics, the work is as discussed earlier, chapter 6 friction, chapter 7 circular motion from HCV. You understand what you have to do, no?
Yes, sir.
So work on that. Next class, we'll discuss any doubts, anything in both the subjects, whatever is the problem. Okay.
Yes, sir.
Okay. Fine. That's all for now then. I'll see you next class.
Thank you, sir.